right. So 8606 VFD system fault communication. 8646 is the communication lockout. 8815 unexpected reset, and 8855 the unexpected reset lockout. You see these codes go hand in hand, and these codes a lot of times go together with other codes. So going back to what I said before about, looking at all of the fault codes together as a whole, um, there are some faults that occur that the PCM initiates a VFD reset. Okay. So if you get a VFD reset, hey, guess what? You also get a VFD communication fault with that. Okay. So, to see some of these 8606 with a VFD reset, to see those together, I expect that. Now, then the question would be, well, why is the VFD being reset by the PCM? Okay, so that's where, we look at all the codes together as a whole and see what is it trying to tell us. Okay, so communication between the VFD and the PCM is happening constantly. If it does not happen for a continuous 15 seconds, then you get the 8606. If you have 3 occurrences within 15 minutes, then you get the 8646, which gives you a 1-hour lockout. When 8606 is set, the VFD shuts down the compressor and the fan and will reinitialize, attempting to reestablish communication between the VFD and the PCM. Most of the time, what you want to look for is the harness connecting the two. Okay. So this part here, this is our VFD communication harness on the left that goes straight up to the VFD. So if we could follow the wires, they'll go right up to this point here at the VFD. Okay, so we want to inspect that harness. We want to make sure that the wires are in there. They're not pinched. They're not falling out of the harness, anything like that. And make sure that's okay. Now, the 8815 and the 8855 are here because they are also communication error. They can occur with numerous other faults and can happen when the PCM resets the VFD. Essentially, the PCM is just power cycling the VFD, so it would lose communication. That should be expected. All right. What you want to do is look at the wiring diagram. Okay. You can see it here a little bit better. VFD communication, right? VFD comms is a 7-pin plug, okay, only 6 wires, and it goes up to a 6-pin plug on the VFD. So that is the plug that I'm showing you here in this case, on the left and on the right. Okay, 2458 PCM power out of range. All right, the PCM supplies 5 volts DC to the VFD through the communication harness. Remember, back in the beginning, we talked about the different LEDs on the VFD. Well, one of them is a 5-volt DC, okay? So if this voltage is interrupted, the VFD will not communicate with the PCM. The PCM will continue to operate for a short period, but if it's interrupted or the communication is intermittent, if the voltage is not restored, the system will shut down and declare 2458. The fault clears once the 5-volt DC signal is restored to the VFD through the communication harness. All right, so the equipment will not operate during this time. So we need to verify the PCM is providing 5 volts DC to the VFD by checking pins 3 and 4, which are the black and red right here. And let's see, red and black. Okay, we want to check for 5 volts DC there. You want to check it coming out of the PCM and going into the VFD. Okay, you want to make sure you have that voltage all the way up there. Here's red and black here. You can check it. And here's our picture. So you can see, I'll zoom in a little for you. Okay, so you can kind of see here between the black and the red, okay, we're getting in with the thin meter leads into the plug while it's connected. I got 4.9, okay, so call it 5 volts DC, and I am checking at the VFD. Okay, now if I start checking here and I read 0 or maybe 1 or 2 volts, then the power's out of range. So what I would need to do at the next point is come down to the PCM and see, am I getting it out of the PCM? Okay, so you can see I'm checking here, black to red. You should have 5 volts DC coming out of the PCM. And in this case, I do 4.9. All right. If I read a low voltage here and it was connected to the VFD, then my next step would be to pull this plug off the VFD and then check it again. Check it here and see, do I have the 5 volts? If you pull it off the VFD and all of a sudden the voltage appears, hey, there's my 5 volts, then I would check, oops, sorry about that. I would check at this plug with it removed. With it removed and holding it in my hand, am I getting the 5 volts DC to this point? If I am, and then as soon as I plug it into the VFD, the 5 volts drops out, well, I could have an issue with the VFD, okay, dragging that voltage down. Of course, if you have it disconnected at this point and you are checking right here, okay, and you're not getting the 5 volts out, you could have a problem with the PCM, okay? If I had a problem with the 5 volts here and it was disconnected from the VFD, I would start looking at my sensors, okay? Remember the sensors are on the right side of the PCM, okay, where I just highlighted here. If you have a shorted sensor, hopefully you would have a shorted sensor fault, okay? But you could have a shorted sensor dragging that DC voltage down and interrupting your communication between the VFD and the PCM, okay? So not too difficult, but you just gotta start with the process. Let's see if I get back to my wiring diagram here. So it might make a little more sense here if you're looking at this diagram. Okay, so here's my VFD comms. I'm going to check for 5 volts DC between red and black. If I do not have it, then what I want to do is disconnect the VFD, okay, at the VFD J5 plug. If I disconnect it and the voltage comes back, then I want to check at the plug with it in my hand and make sure it's getting to the end of the wire. If you plug it into the VFD and the comm drops, then I probably got an issue with the VFD. Now, if you've disconnected this plug, okay, it's pulled off, and I don't have the 5 volts DC here, then what I want to do is start checking these sensors. Okay, check these sensors and see, are any one of them shorted? Hopefully you would have a shorted sensor fault. But if you don't, you could start pulling the sensors off and see, does my voltage come back? You know, if I pull off one of these sensors and all of a sudden, hey, I got voltage, well, I probably got an issue with that sensor, okay? 8216 VFD system fault, low line voltage, and 8256 low line voltage lockout. Now, this is a little different. We talked earlier about the voltage that was read by the transformer on the secondary side. This line voltage fault is actually read by the VFD itself. Okay, now I can go onto the user interface, HP status, AC status, whatever, and look at my line voltage. It'll tell me right there. Okay, and it's reading that from the VFD directly. Now, if you have voltage that drops below 180 volts AC, then you get the code 8216. Okay. After 4 occurrences in 1 hour, then you get the 8256, which is a lockout for 2 hours. 8217 is when your voltage rises above 410 volts, then you'll get the 8217. All right. If it happens 10 events in a 1 hour period, then you get the 8257 high line voltage. Now, 410 volts, that's a lot. It's some spikes could be causing it, power issues, maybe due to a storm or a surge or something like that. But if you're getting those faults, if they're active, then you want to check on your UI, on your app, what is the voltage that the unit is seeing? Okay. And then compare what is my voltage at my terminal block? Okay. And work your way up. 8836 VFD internal fault line sensor voltage and 8876 line sensor voltage lockout. These are kind of the same thing. You want to check your voltage at the terminal block, okay, and work your way up to the VFD. Now remember, there is the filter board in between this point here and this point. Okay, you can't really see it from the picture, but kind of right here is that filter board. Okay, the EMI filter board. You could have a failure in that board and giving you a line voltage sensor issue. But you want to make sure you have the right voltage here and then going up to the VFD. 6641 VFD control relay open lockout and 6642 relay shorted lockout. All right. The PCM commands the VFD to close a relay in the power circuit during VFD initialization. If the PCM senses the VFD relay coil is open, then you get this code 6641. While the code is active, the VFD will not be powered and the system is inoperable. 12 volts DC is fed from pins 6 and 7, blue and white, of the PCM into the blue and white on the VFD. Okay, so here is your VFD control relay. All right, this VFD on the left would be like a 5-ton, and the VFD on the right would be like a 2 or 3 ton. It's similar for the 4-ton. Okay, but there's your VFD control relay. All right, now you can't physically check in that relay, but we can get pretty close. So again, between the blue and white, checking it here on the PCM, you can see me checking it there. Now it says 12 volts DC. This was a properly operating unit, 10.2. Okay, there was nothing wrong with the unit. Okay, so you may have a little bit of fluctuation, or not fluctuation, but a little bit of variance, I should say, with your meter. Okay, so keep that in mind. So going over to our diagram. All right, so here's the blue and white, pins 6 and 7. Okay, blue and white, that should be my 12 volts DC. I should have 12 volts DC up here, blue and white. All right. To troubleshoot this, remove the PCM VFD harness from the PCM while leaving the other end connected to the VFD. You can ohm this VFD control relay. Okay, so what I would do is pull this plug, okay, and then go to the VFD and ohm that plug. Here's a picture you can see where I'm measuring voltage. But if I suspected an issue with that control relay, then I could always ohm it out. Now, again, to ohm it out, you have to isolate it. So you got to pull this plug off the PCM. Then you can come up here and ohm the VFD control relay. The VFD control relay resistance should be 720 ohms, and that's approximate. If the resistance is much higher than 720, then remove the connector off the VFD and check the pins on the VFD itself. Okay, if check your cable, make sure the cable is okay between the VFD and the PCM. If it's significantly more or less than 720 ohms, then the problem's the VFD, need to replace the VFD. Okay, so it's as simple as that. But you got to have the 12 volts, and then it's got to be pretty close to 720. 8513 VFD system fault, DC under voltage, and 8553 DC undervolt lockout. Troubleshooting both faults is the same procedure. Verify high AC voltage on the UI and on the app and confirm it's within specs. Okay, so I'm looking at my line voltage, 244. I look on the app, line voltage, 244. Okay, I should be pretty close. You know, measure it with your meter. What are you reading? If the DC voltage is lower than the acceptable lower limit, which is 180 volts DC, after 4 occurrences within 1 hour, you get the 8553, which is a 2-hour lockout. Okay. 8513 is usually accompanied by a VFD reset. This can happen due to low AC line voltage, quickly loading the compressor, or a damaged PFC circuit in the VFD. We have seen some issues with this fault and the compressor backspin. So I'm not going to beat around the bush on that one. So if you guys are seeing, you know, this fault and your compressor doesn't sound quite like you think it should, reach out to us and we'll cross that bridge when we get there. But you know, I would definitely check some of the most obvious stuff first: connections, line voltage to, you know, line voltage out of the drive, you know, that sort of thing. Check your reactors, make sure they're plugged in, you know, power cycle the unit, and check some of those kind of normal things before reaching out to us. You can also look on here and see the DC bus voltage, okay, and AC line current, that sort of stuff. So you can get an idea, what is the unit seeing compared to what you're seeing. 8514 and 8554 is the other end of the spectrum on that, DC over voltage. Same thing. You know, compare on the app, the UI, and see what do you have compared to what you're actually reading. Okay. 8833 is DC link sensor, and 8873 DC link sensor lockout. Again, troubleshooting these codes is all done the same way. You want to make sure you have your high voltage to the equipment. Make sure it's getting up to the drive through the filter board. Make sure your UI and your app are both reporting the correct voltage compared to what you're reading. Okay. Yeah, again, backing up a little bit here. Check your voltage incoming. Okay, make sure all these connections are tight. No signs of overheating. You may even want to check at the disconnect too. Okay, follow the circuit up. Okay, you can see the yellow and black wires. You follow these up and it goes to the filter board. Okay, here's one. It goes through this filter board. There's a couple fuses here, kind of hard to see, but there are fuses on this filter board. Okay, it goes through the filter board and out of the filter board up to the VFD. Okay, so you want to make sure the voltage is getting into the filter board, out of the filter board, and eventually up to the VFD. You can see the yellow and black plug right here. Okay, now if you want to know what the DC voltage is, and you know, you can see it on the UI, and that's great. But if you want to read it directly with your meter, so you know that you know what you're seeing is what the unit is seeing as well. There are two terminals on here. And kind of hard to see from the picture because the alligator clips are on there, but there's two DC terminals here that you can grab with your alligator clips, turn the unit on, and then read your DC voltage, okay? So check your voltage at the UI, and then check it, at the VFD itself. 8213 VFD reset with the power drop out. 8253 is the corresponding lockout. 8215 fault with the power drop out, and then 8255 lockout. Okay. These are power related, power drop out faults. Typically, I see these when it's the middle of the summer. And in Florida, we have our afternoon storms, mid to late afternoon storms. The storm rolls through, and then an hour later, 2 hours later, hey, the unit's still off, and you get 8253, 8255, whatever. Okay. You can get these faults due to line voltage loss. Okay, 4 occurrences within 1 hour gives you the lockouts, which result in a 2-hour lockout. Like I said, momentary power loss, electrical noise. You might see these paired with other electrical noise codes. Of course, check some of the obvious stuff, right? Check the tightness of your connections, all the way up to the VFD itself. You could have, power issues with afternoon storms, connections, something like that. You may want to consider, in fact, it's highly recommended to use a product like this, which is the ICM 493. The ICM 493 is about as big as a disconnect, maybe a little bit bigger. Okay, but I do have a short video here made by one of our customers, and I want to show you guys this for your knowledge.
Okay, today we're going to go over how to properly install an ICM 493 single phase voltage monitor with surge protection. We're doing these on all of our Infinity systems that have inverter boards. On this particular one, we have our service disconnect on the right hand side, and then we have our ICM 493 here. So first off, we're going to want to come out of the disconnect into our voltage monitor surge protector here. On the back side of this, I'll show you how it's actually wired up. So on the left-hand side, we're monitoring voltage. And then once we know our voltage is in line, then our board is going to activate our contactor, which is then going to send voltage to our actual condensing unit. Again, so our line voltage is going to be wired in to the left-hand side, and then our load, which is our condenser, is going to be wired into the right-hand side. On this board, you also have a 3-amp low voltage fuse. All right, so that's pretty much how it's wired up. You have 4 different Capcons: upper left, upper right, lower left, lower right. This upper left one's a little bit tricky to get in, so you do have to remove these 2 screws to get easy access to that upper left-hand side. Obviously, make sure everything's perfectly level. Silicone the top portion that's up against the wall. So then you close it up, This particular one has a set screw right here. You can go ahead and put that in and we'll go through the programming. Okay, so for our setup on the ICM 493, you just push the actual setup button. So first you're gonna push the setup. It's gonna ask you the line voltage. So what is this appliance? Is it a 2A, 240, whatever it may be? This particular one's a 240. Over under voltage percentage. So we are going with 5%. Under or over 240 volts will actually open the contacts that's providing voltage to our load. So we want to go with 5%. Then we're going to have line voltage 240 over under, anti-short cycle delay. This comes at 30 seconds. I bumped it up to 2 minutes. Reset mode, so you can change this from one trial or automatic. I went over the pros and cons with the customer and we chose to go with automatic on this one. Allowed MOV fails, 5. This one you can also change that as well. We're gonna go with 5. And that's pretty much it as far as the setup goes. The last step is actually calibrating the ICM 493. How you're going to do this is push the up and down arrows until your line voltage starts to flash. And with a RMS meter, you're going to check your line voltage between L1 and L2. Go up and down as required. This one's already dialed in at 242 volts. Once you got it dialed in, you just push the setup button and you are good to go. Those are all done. So remaining MOVs is 5 and the actual voltage that we are receiving is 243, and that'll fluctuate. This one's fluctuating between about 242 and 243.
All right, so pretty informative video, and I'll tell you, these guys install these ICMs on all their inverter equipment, and we don't hear from them. Very rarely do they call us with an inverter problem. So highly recommended you guys put those on any inverter system. Okay. 8211, 82 or 8311, this is line current limit. Okay, so these are all current faults. 8312 is a current 2 and 8357 is a VFD compressor current fault. Okay, again, it's keeping the compressor in the happy place, a safe operating range. If you're getting these current faults, then what draws, what causes the compressor to draw high current? Right, overcharge, high condensing pressure, that sort of thing. You may need to recharge the system, do a complete recharge, recover the gas, evacuate and recharge it in. Okay, that could be something that's an issue there, causing a high current. Okay, 8315, 8355, there's your current 3, and 8316, 8356 at your current 4. Check the compressor resistance. Okay, you can see the resistances are at 68 degrees. So, if you're above or below that, there could be a little bit of variance. Okay, obviously we should have OL to ground. If we're reading, 0.42 to ground, it's a dead short. Okay, so check your compressor resistances. Look at the connections. Like I said, what causes high current? Poor connections. Check your connections at your VFD. Check your wiring harness, your high voltage wiring harness going to the compressor. Okay, take a look at the compressor plug. pull the plug off. In this case, I had a couple of these current 3 and current 4 faults, and I had the guy pull the plug off, and hey, look at that plug. Doesn't look very healthy. Okay. Took a look at the compressor terminals. There you go. Okay, there's a problem with that compressor. There was a poor connection that caused a high current draw, and eventually the terminal burned. Okay, so that's a compressor failure. VFD system lockout is a wiring error. That's 8158. 8831 is internal fault current sensor, and then 8871 compressor current sensor. The 8158 is that the VFD sensed one or more of the compressor wires were not connected to the VFD. Okay, that's when can that happen? Maybe you replaced a compressor or you did some kind of work inside the condensing unit and there's no wires on the compressor, or you're missing one of the wires, something like that. But you could also use that fault to your advantage. Hey, if I suspect an issue with the VFD, well, will the VFD determine a wiring error? If I pull the wires off the compressor and try to run the system, I would expect the VFD to correctly identify a wiring error. If it doesn't, well, that could help me in determining if I have a problem with the VFD. If I'm kind of at that situation, well, it's a VFD or maybe it's something else. Let me cause this fault by disconnecting the compressor. And if it correctly throws the fault, then that might help me in determining what my next step is. Okay, so you can use that one to your advantage. You can see the picture on the left. You really cannot mess up that plug. It's polarized. The one on the right, yeah, you could, inadvertently put one of the wires in the wrong spot, so that could happen. Could be an issue with the compressor itself. Check your winding resistance, ohm it to ground. Compressor no pump lockout. The what's that? 3854. The diagnostic checks ensure the compressor is running in the correct direction and pumping properly. Once the compressor speed is greater than 400 RPM, the compressor has up to 30 seconds to increase pressure differential between the discharge and suction by 20 PSI. Okay, if the pressure differential is not met, then you get the code 3854. What could cause it? Maybe an issue with the compressor. Could be an issue with the transducers. I've seen that happen. You get a compressor no pump lockout and you're saying, hey, that doesn't make sense. You start digging into it and hey, guess what? The unit came on, it started to run, the differential was not met, and then it gives you a compressor no pump lockout. But when you're looking at your gauges physically connected, you had differential. It's just the system did not see it. Okay. 3813 is VFD compressor start fail, and 3853 the corresponding lockout. Okay. Similar way to approach that troubleshooting. Check your compressor, check your wiring, check your transducers, make sure the system is identifying that it's correctly running. Okay. 3831 is a compressor estimator and the lockout. These are rare. I don't know if I've seen one of these codes occur, but it's used in the compressor starting process. When the fault is active, the PEV will open and the compressor will continue to attempt to restart. After 3 codes of 3831, you get the 3871 and a 4-hour lockout. You could have high starting torque, possible compressor damage. Ensure the VFD is correct for the compressor that you have, and ensure that all the parts are correct for the model being serviced. You may have compressor damage if you have that. But again, in the last couple of years, I don't think I've seen the 3831 or 3871, at least that that I'm aware of. 3315 low discharge shutdown, and 3355 the lockout. Okay, I'll show you a video here. You can see clearly a leak. You can see the bubbles on the braze plate heat exchanger. Now, I'm not saying you'll get these faults if you have a leak on the braze plate heat exchanger, but any leak in general, okay, low discharge pressure you can get from a leaking component inside the system, okay? um, Same thing, going back to this one, check your transducers, make sure the transducers are wired properly. The unit is very good at keeping itself in check, but if it's receiving the wrong information, then it's going to act according to what it's receiving. It's kind of like when I'm helping a guy troubleshoot a system and I say, okay, check your voltage here, check your voltage there. And we're going down the circuit in a proper troubleshooting, format. And he says, well, I have no voltage here. I'm like, but you just told me you had voltage there. It's impossible. You're giving me wrong information. So I'm going to misguide you if you give me the wrong information. Well, the system acts the same way. If it has the wrong information, it's going to act accordingly based on that information. So, we we got to look at that when we're troubleshooting these units. Low compression shutdown and the lockout, that's 3615 and 3655. Again, most of the time that occurs is due to a leak. I'll show the video again. You can see clearly a leak. Any leaking component could cause low compression. Okay. 3511, high compression limiting. 3558, compressor high compression lockout. And then 3411, high temp limiting. 3658, high temp lockout. Okay. Looking here, high compression ratio, high return gas temperature. These are the number one and number two causes for compressor failure. Okay. And so that is what this is telling you. High compression, and high temperature limiting, it's limiting the operation of the equipment. Okay, that's the number one and number two failure. What can cause a high compression ratio? Recirculating discharge air. If you look at this unit, the way it's installed, that air is hitting the eave of the house and coming right back down and just recirculating, artificially driving up the head pressure to a point we get to this high temperature limiting, high compressor limiting, and lockout. Okay. Maybe the unit's overcharged, and that's why you have a high compression, limiting fault occurring. You may need to recharge the system. I threw this one in there. It's in the back of the manual. It's pretty neat to see some of these voltage readings. If you want to know, hey, what should the voltage be on that sensor? It gives you some of that stuff. You can see the PEV, the reversing valve, 24 volts. We kind of talked about some of this earlier, 0 to 12 volts. So that one's in there. Again, it's in the back of the service manual as well. Okay. But we got I don't know, a couple minutes here. If anybody has a question, you feel free.